Hello, everyone. Today, we're going to talk about the converse of the Pythagorean theorem. Now, remember, converse means we're going to flip it around. We're going to look at it at a different angle and try to determine if triangles are acute, obtuse, or right, depending on the results that we get from a variation of the Pythagorean theorem. So the first thing is to create a triangle, the sum of the lengths of any two sides, and most of the time I pick the smallest two sides because that's where most of the you can be able to determine this, must be greater than the length of the third side. Can the following sets form a triangle? So what we're going to look at here is we have four sets of numbers. Okay, now if I add any two of these numbers and it's greater than the third one, then we can form a triangle. Now, if you pick one of the numbers to be the largest one, then it's always going to work. So I always try to pick the two smallest numbers. So in this case, if I add 4 and 5 together, I get 9. And is 9 greater than 7? Yes. So this can be a triangle. What about 3, 9, and 6? So my two smallest numbers are 3 and 6. Now, here's the question. For this to work, it has to be greater than the other one. 9 is not greater than 9. So this one is a no. This cannot be a triangle. Okay. The next one, 8, 2, and 3. 8, 2, and 3. 2 plus 3 equals 5. Is 5 greater than 8? No. And then the last one, 12, 13, 14. 12 plus 13 is 25. Is that greater than 14? Yes. Okay. So I'm going to go back over here. Insert this image right there. Okay. Okay. So we've determined whether or not, oops, I put that on the wrong one. Let me go back. All right. Okay. So now we can also use this to determine if it forms an acute triangle. So if a squared plus b squared is greater than c squared, then it forms an acute triangle. So the question is, can the following sets form an acute triangle? Okay, so we have two sets of numbers here. I already have them written down. Now, to determine A, B, and C, you for sure want to pick the two smallest number as your A and B, and then that's your C. So the question is 11 squared plus 17 squared greater than 22 squared? Now, this is where the calculator is going to come in very handy today. So 11 squared plus 17 squared. Now, I can do this all at once. Move it over here so we can see it better. So that's 410. And then what's 22 squared? 484. So is 410 greater than 484? Because remember, for it to be acute, it has to be greater than. So no, this is not greater. So not acute. Now, Don't let these throw you off. Okay? Square root of 3 squared plus square root of 4 squared, is that greater than square root of 5 squared? Now, I'm going to show you a couple of ways to do this. Okay? Anytime I'm doing these, there is parentheses here. I always like to put these in parentheses just to make sure I'm not making a mistake. And I'll show you why on our last problem today. So I'm going to put in, remember I hit second square to get that square root sign, 3. And I'm squaring that, plus square root of 4. And you get used to pushing the buttons, pushing the over arrows. That is 7. So what I wanted to show you real quick, anytime you square a square root, so square root of 3, I'm just going to show you this one more time. Anytime I square a square root like this, you're basically just getting rid of the square root. Okay? So the square root of 5 squared is just 5. Okay? So 7 greater than 5? Yes, this is acute. So I'm going to go here, insert the image, and there you go. And then, of course, can we determine if it's a right triangle? If a squared plus b squared equals c squared, which is the Pythagorean theorem, then it forms a right triangle. So here's my a, b, and c. So does 11 squared plus 25 squared equal 27 squared? So 11 squared plus 25 squared is 746. 27 squared is 729. So does 746 equal 729? No. Not right. Not a right triangle. Again, A, B, and C. Sometimes these won't be in order, but if you want to know, if you just put in 5 square root of 2, you just plug it in, you see that it's really 7.07, so that's the longest side, so that's why that's going to be C. But 5 squared plus 5 squared, does that equal 5 square root of 2 squared? So let's do 5 squared plus 5 squared first. I get 50. Is that equal to? Now, here's the reason I like you to do these parentheses. If I were to do 5 square root of 2 squared, I get this. Okay? But if I do it in parentheses, it's squaring the whole thing. Oops. And see a difference? Big difference. Okay? This is the answer that we're looking for. So you have to put it in parentheses. So does 50 equal 50? Yes. This is right. Right triangle. So I'm going to insert. And then the last type of work we're going to look at today is obtuse. If a squared plus b squared is less than c squared, then it forms an obtuse angle. So I have these last sets of numbers. Now, notice these are out of order. So this is A, this is B, and this is C. You can't just write it down. If you want to rewrite them, 12, 22, and 29 in order to help you out, then that's what I do. 12 squared plus 22 squared. Is that less than 29 squared? So again, let your calculator do most of the work. 12 squared plus 22 squared is 628. 29 squared is 841. So is 628 less than 841? Yes. So this is obtuse. And which one of these are, let's double check to make sure, see which one's the longest. 5 square root of 3 is 8.66. So I'd make this my A, make this B, and then that's your longest one, C. You always want the longest length to be C. So does 5 squared plus 5 square root of 3 squared, is that less than 10 squared? Okay. So I'm going to do this side first. 5 squared plus, and be sure and put in parentheses, 5 square root of 3. And notice how I hit that over arrow to get out of it. Squared. So that's 100. And 10 squared is also 100. So is 100 less than 100? No. So this is not obtuse. Now, if we go back to some of these, see how we said this is not acute? It's not acute, but since it is less than 484, this is obtuse. Since this is greater than, it's not right, but it's acute. So on and so forth, okay? So I'm going to take another picture, insert that in, and there you go. So that's what we're going to be doing today. We're going to be determining what type of triangles we have. Okay? If you have any questions, let us know.